Good morning, good afternoon, good evening, mammals. This is my third in a series of 4 videos, kind of doing some review breakdown of macromolecules. You can find all of them on my YouTube channel. In this one in particular, we're going to talk about lipids, and just like the other two, I'm going to go over how to identify the lipids, what functional groups to look out for, how individual monomers assemble themselves to make a larger polymer and what those are called, and then their biological functions. Okay, starting with identification, we're going to break down our lipids into 4 groups. The first 2 are fatty acids. They're very similar. What you will see functional group-wise for fatty acids is you will see this carboxylic acid. If I can spell. And you're going to see a long chain of carbon atoms. We break these down into saturated and unsaturated fatty acids. The difference is going to be in if there's a double bond in the carbon chain or not. If you see one, could be more than one, but if there's one double bond in the carbon chain, it's going to be an unsaturated fatty acid. They both have the carboxylic acid. Just to remind you guys, the shorthand of these, all of these N's and B's here could be carbon atoms. So sometimes for simplification, they're not labeled. But if we wanted to label them, all of these intersections could be carbon atoms. And they would have however many hydrogens that they need to make 4 bonds. So this guy down here at the end, there's only 1 bond shown. He would have 3 hydrogens hanging off of him. The ones in the middle, they've got 2 bonds shown, so they would have 2 hydrogens. So there's a video posted about how to break these down if you need to. Sometimes they're shown with carbon atoms labeled. Sometimes they're shown just in this simplified form with the zigzag line for the carbons. The other 2 categories of monomers are steroids and sterols. And just like the fatty acids, they've got some similarities in their structure. What you will always see is this 6665 number of carbon rings. So in both of them, there's going to be 3 6-sided carbon rings and 1 5-sided carbon ring. And they're always going to be in this shape, where the 3 6s are connected together, kind of like a beehive honeycomb sort of thing. The difference is the oxygen that's hanging off the end. If it's a steroid, it's going to have a double bonded oxygen. If it's a sterol, it's going to have a alcohol, an oxygen and a hydrogen hanging off the end. So these are other 2 subcategories of fatty acids. The polymers, we won't worry about making polymers out of the steroids and sterols. The only ones that you'll have to worry about is making a polymer out of fatty acids. And their polymer is always made of 3 fatty acids. So I've got 3 fatty acids here. They could be the same, they could be different. One could be saturated, the others could be unsaturated. It doesn't matter. You've got 3 of them. And then you have this molecule, which is glycerol. And we have our old friend dehydration that joins these together. So like in the other dehydration processes, we get an OH from one molecule and a hydrogen from another molecule that come together to form a water. And then the molecules are joined together where those atoms were removed. Just now, for this is going to happen 3 times. And so our product is going to look, there's the leftover of the glycerol. and it's going to be bonded to the 3 fatty acids. And this polymer, for obvious reasons, is called a triglyceride, because it's a glycerol that has joined with 3 fatty acids. So that's the only polymer that you need to worry about for lipids. Lastly, to wrap it up here, I'm going to talk about functions. Lipids, the function that probably everyone associates with them is energy storage. We all know what that extra stuff around our midline is there for. It's stored energy in the form of fats. But it does a lot of other important things for us too. It provides structure in the cell walls. It also provides a lining in between different layers of muscles so that they can slide past each other. So lipids have important functions in that. And they also have important functions in signaling. We mentioned steroids and sterols. Steroids are there to tell your body to do certain things. Sterols, cholesterol is the one that everyone knows of. People kind of have that bad connotations about it, but it serves important functions too. It helps you make important vitamins like vitamin D, and actually can then be used to produce steroids. So actually having too low of a body fat percentage can lead to problems because you don't have enough lipids in your body to produce important things like steroids. So that's going to wrap it up for the functions of lipids. As always, take care of yourself and others, practice good hygiene, and I'll see you on the flip side.